Hi everyone, my name is Ramesh, 21951 F0 of branch ECC section. In this presentation, I am going to talk about applications of thevenin's theorem. The contents are Thevenin theorem, application, limitations, advantages. The first one is what is Thevenin's theorem? Thevenin's theorem states that any combination of voltage source, current source and resistors with two terminals for a linear circuit is electrically equivalent to a single voltage source V and a series resistor R. Any complex circuit can be represented by a Thevenin's equivalent circuit consisting of a single voltage source and a series resistance connected to a load. Uh, Thevenin's theorem. Any two-terminal DC network can be replaced by an equivalent circuit consisting of only a voltage source and a series resistor. In other words, the current flowing through a resistor connected across any two terminals of a network by an equivalent circuit having a voltage source E Thevenin in series with a resistor R Thevenin, where E Thevenin is the open circuit voltage between the required two terminals called the Thevenin's voltage, and the R Thevenin equivalent resistance is of the network as seen from the two terminal with with all other sources replaced by their internal resistance called Thevenin's resistance, and this is a Thevenin's equivalent circuit. In this we have R1, R2, R3 load resistance and Vs voltage source. Let us consider a simple DC circuit as shown in the figure, where we have to find the load current IL by the Thevenin's theorem. In order to find the equivalent voltage source, RL is removed, that is, load resistance is removed from the circuit as shown in figure below, and Thevenin is calculated. In this circuit, the load resistance is removed, and the Thevenin is IR3 is equal to Vs by R1 plus R2 into R3. Now, to find the internal resistance of the network, the Thevenin's resistance or Thevenin's equivalent resistance. In series, the in series with the open circuit voltage, that is VOC, also known as Thevenin's voltage, V Thevenin, that is, uh, the voltage source is removed, or we can say it is deactivated by a short circuit, and the source does not have any internal resistance as shown in figure. We have to short circuit the voltage source, that is next to, we have to calculate R Thevenin's. R Thevenin's is equals to R2 plus R1 into R3 by R1 plus R3, that is. After the circuit, as per the Thevenin statement, the load current is determined by the circuit shown above, and equivalent Thevenin circuit is obtained. The load current IL is given as IL is equals to load current is equals to V Thevenin by R Thevenin plus load resistance, where V Thevenin is the Thevenin's equivalent voltage. It is an open circuit across the load terminal AB. R Thevenin is the Thevenin equivalent resistance as seen from the load terminals, where all the sources are replaced by their internal impedance. RL is load resistance. The steps of Thevenin's theorem. The step 1, At first, remove the load resistance RL of the given circuit. The step 2 is by the internal resistance replaced all the impedance sources. And step 3 is if the source if the sources are ideal, then short circuit the voltage source and open the current source. The step 4 is now the equivalent and the load terminals known as thevenin resistance, that is R thevenins. And step 5 is draw the thevenin equivalent circuit by connecting the load resistance, and after that determine the desired response. And the second one is application. It is very useful for analyzing power systems and other circuits where one particular load resistor in the circuit and recalculation of the circuit is essential with each trial value of load resistance to find the voltage source across it and current through it. Source modeling and resistance measured by using the Wheatstone bridge provide applications for the Thevenin's theorem. Practical limitations. If circuits are not only linear over an indicated range of values, thus the Thevenin equivalent is valid only within this linear range and may not be valid outside the range. Uh, the Thevenin equivalent has an equivalent IV characteristics, that is current voltage characteristic, only from the point of the view of load. The power waste of the Thevenin equivalent is not necessarily similar to the power dis- uh, deception of the real system. Whatever the power waste by an external resistor between the two output terminals is similar, but the internal circuit is represented. The fourth one is advantages. What are the advantages? It reduces a complex circuit to simple circuit with a single source of EMF. Each Thevenin is equal in series with a single resistor R Thevenin. It is greatly simplifies the part of the circuit of the lesser importance and enables us to view the action of the output part directly. The theorem is especially useful to determine the current in a particular branch of a network, as the resistance of that branch is varied while all the resistance and EMF source remain constant. Thank you.